from the Lowell. We are here in Devens today to cover this event, Devens Robotica 2015. And about 50 companies are here, technology companies from Eastern Massachusetts are here to exhibit their technologies.
My name is Chris Redding. I work for Kinetic North America. This is our drive robotic system installed on a Bobcat E35 excavator. It basically converts the manual excavator to robotic control. Anything you can do in the cab, you can do from this controller. All your feedback is on the screen. Any error codes, everything is come back to you right here. But with the flip of a switch, you can go back to manual mode and use it just like you would in military products. So these are all for EOD or explosive ordnance disposal. So the Talon here is kind of our workhorse. We have over 2,000 of them overseas with the U.S. military and the Marines. And that is what they use to investigate IEDs on the side of the road. They'll sometimes use a disruptor that can be mounted there to actually separate the IED without exploding it, or sometimes they'll just take a pack of C4 and drag it over to the IED, leave it there, and bring the robot back to safety and detonate, do a sympathetic detonation and detonate the IED. You know what you want to do?
Oh, it has a camera on it?
Yep, so it's got 5 cameras on it, or 4 cameras on it at the moment. One on the top there can actually pan and tilt, so you can point it at whatever you want. And then it's got one on the front, one on the upper arm, or on the gripper rather.
Just FMTVs, the brand new ones are designed to be changing operation. And that really it's not going to be efficient.
Yeah.
Where a person can get and drive.
You can drive under cars. There's a camera right here that actually can point up, so you can see underneath cars to see if there's anything stuck to the frame, you know, bombs or tracking devices, things along those lines.
Robotics is an area
it gets a lot better going into tighter places like culverts, things where they might have buried an IED. And then you've got this is our
Jeff Adams, co-founder and president of Unmanned Aerial Systems Development. And what we have here is our heavy lift UAV that we built out specifically for film production, television, content production, and advertising aerial cinematography.
Can you tell me a little bit about the device?
Yeah, so what we have is a multi-rotor UAV, an unmanned aerial vehicle. The system is built up to have a flight control platform where the pilot can move our camera systems around. And then the second part of our system is a 3-axis stabilized gimbal with a capacity to carry production-grade camera systems and their required componentry. The effect of that, or design for that, is so that the camera then is not limited by the motions of the airframe as to where he can point the camera or follow the direction of the production crew. And the airframe has the capacity to lift a significantly heavier
it's on a tripod.
It can do that as well. So we built it out, like I said, basically as a service piece of equipment for film and video production. And you know, we're awaiting authorization, licensing from the FAA to do that. But as soon as that comes through, it's going to be ready to work.
How high does it go?
It'll go up until it runs out of atmosphere, but we're going to operate under 500 feet, which is the standard authorization that the FAA has been issuing. And in reality, most of the work that we'll be doing will probably be from about 6 feet off the ground up to 100 feet. That's kind of the sweet spot where this technology really returns its, you know, the greatest benefit. If you're filming a long shot at 500 feet, you're probably better off having a manned aircraft, just because the wind currents at 500 feet are so strong, and the cameras that you'll be wanting to use at that height are so heavy and robust that, you know, beyond that sort of sweet spot of 6 feet to 100 feet, you're probably going to be better served with a fully manned aircraft that can carry a lot more weight than that.
Tom Phelps, I'm the Director of Robotics Products for North America for iRobot Corporation.
What do we got here today, Tom?
So what we have here are 2 examples from our family of robots. This is the 510 TACBot. that is outfitted with a radiation sensor as well as an environmental sensor and a mapping payload. So what this robot would be able to do is to go downrange, map an area, identify where the robot is on the map, and if you actually got hits on the radiation sensor indicating high degrees of radiation, you could actually identify where they are on the map. So you'd be able to triage the scene before you went downrange. But the key piece that we have here is our new U-Point multi-robot controller. So this multi-robot controller will be able to control our entire family of robots in the coming months. And it basically takes all of the intuitive touchscreen technology that people are familiar with, so slider bars, being able to drive the robot. We like to say if you can play Angry Birds, you can now control a robot. We go into controlling the arms. We have slider bars where we can control the arm joints. You can also use the slider bar to rotate the arm. It greatly simplifies the user interface and makes it very easy for operators that do not have the ability to play with the robot every day to get very proficient at the robot and maintain a high level of proficiency. The radiation sensor and the environmental sensor, so we're getting the sensor readings real time. So if we actually had a high radiation measurement, it would alarm here and tell you that you had a high radiation measurement. We also have maps where you can actually see where the robot is in relation to the operator, which is very important if you're dealing with standoff distances from chemicals or improvised explosive devices. As I move joints, for instance, you can actually see it moving on the 3D model also. We have things such as poses to help the operator transition. Let's say now I wanted to drive. I could go into the drive pose and it would automatically get into the drive position.
So this is specifically for radioactive?
No, so this is a multi-mission robot. This is being used in a wide variety of markets. It's being used by the counter IED teams, the EOD teams. It's being used by bomb squads. It's being used by tactical teams in barricaded suspect hostage negotiations. Same robot is also being used in nuclear power plants for radiation monitoring and handling hazardous materials. This is the same robot that's still in use in Fukushima Daiichi. So it was provided to the Japanese government right after the tsunami and the issues that they had at the meltdown at the nuclear reactor. So it's still being used today. So it's withstood those high radiation.
My name is Richard Kelley. I'm a managing engineer at Exponent, and I'm part of the thermal sciences practice. And we are here at the show exhibiting our technology our expertise in unmanned systems and robotic technology. Those are about 15-year technology now. These are robots that we made specifically for the military, the U.S. Army, because they wanted to be able to. Before these robots came on, the way soldiers were trying to figure out if something was an IED or not was to either poke it with a stick, or wait for an IED team, an EOD team to arrive, which would take 8 hours or something like that. So the soldiers wanted a simple means of being able to inspect whatever the suspicious device was. So they wanted something quick. So we helped with a part of the military called the Rapid Equipping Force in coming up with these very cheap, very quick to build robots. These are called the Mark bots. For the radio feed. So and on the tip we have light, and a camera. So it's pretty simple stuff.
And does it do something to make things explode or anything?
No, it's just for inspection. You can go and see what your box is, what does it contain, and so on. And you know, it's built on like an RC car base, a fairly expensive RC car base, but you know, it's something that's cheap. It can be repaired fairly easily. It can be put together fairly easily. Those kinds of things. It's very.
I'm Barry Bronstein with Acorn Product Development. Acorn Product Development is a product development firm that takes customers' ideas, napkins, sketches, what have you, and turn them into manufacturable products. We serve a variety of industries, including medical, industrial, military, datacom, telecom, and consumer. And we're here at the robotics show to show off one of the products that we developed for a company called Robotex. This is a robot that is designed for first responders, where it's a surveillance robot so that you can assess a situation before you would send in a person to see whether or not it's safe to send something. Are you testing just terrain? Are you testing weather? Are you testing all of those kinds of things? For a product like this, you would put it through extensive testing with water, with rough terrain and things like that, making sure that it's robust enough. You drop test it, which we did on this project. So you'd use a center like that.
You want to race? Oh, he wants to race. He wants to race you.
You say the Pacific?
Asia Pacific Invitational.
Okay.
He's just a freshman this year. Okay. Because it's aimed to get kids into science, technology, engineering, and math. And so they give us a competition, get us to build a robot using the engineering process. So this year, what they asked us to do was pick up these wiffle balls and golf balls and then put them into these cylinders like this. There are 3 types of these cylinders, and there's one that's 30 centimeters, one that's 60 centimeters, and then one that's 90 centimeters. And there's also one that's fixed at 120 centimeters. And so we got to make a robot that will fill. And so the game runs 2 minutes 30 seconds, and for the first 30 seconds the robot drives all by itself, and it uses sensors to figure out where it is. So we have sensors here and here and here, all to figure out where the robot is. And then after the 30 seconds you control it with the PlayStation controller. And so then drive around the field for 30 seconds, and what we've done is we have the spinner on the front right here, spins, kicks the ball all the way up here, and then we use this lift to lift it up, and then drop it into the bucket. It's a little out of alignment right now, but we're working on it. So it can go all the way up to that height, which is the maximum height we needed to even get to. So we've done pretty good this year. We went to the state competition where we competed with the top robots in the state, and we went to the semifinals. We ended up getting knocked out. However, we did get invited to go to Australia in about a month or so. And we were prepping the robot for that.
My name is Adam Norton. I'm the manager of the New England Robotics Validation and Experimentation Center at the University of Massachusetts Lowell. And we're here at the Robotica 2015 event with a miniature version of our facility, smaller versions of test methods that are used for response robots, for mobility, manipulation, sensors, demonstrating some of our robots' capability. Climb over obstacles. It doesn't have a manipulator, so a lot of these tests don't necessarily apply. But as you can see through our camera system, we can get a good reading as to how well, how high resolution this camera is by being able to resolve these different levels of detail. From here, I was looking at one of those C's, and through the interface, I can see all those different levels, so I have some measure of acuity that I can claim for this robot's camera.
I see.
These terrain, again, like I said, is not very natural, but even just this idea of pitching and rolling, needing to kind of change your form factor to fit over these different obstacles, is all it's meant to be replicated. Because Now we could just have a rubble pile, but it's very hard to standardize and replicate a rubble pile. So when we have tests like this that are easily buildable and can apply to all different types of robots, we can compare apples to apples for Robot A and Robot B on the same test and use those to quantify the performance.
Mike Moore, and I work for Stanley Innovation in Merrimack, New Hampshire. We're a Segway technology integrator and reseller of the RMP robotics platforms. We're located in Merrimack, New Hampshire, and having fun at Devens Interoperability.
My name is Colleen Anderson with Harmonic Drive, and we make gears and actuators for robotics applications. We're here to meet with a lot of our customers here at the Fort Devens. Oh yeah, I forgot to tell you, these are they're springs.